Hey everyone, and welcome to this explainer. I am so thrilled you're here today because we are setting the stage for a massive paradigm shift in how we view maintenance planning and asset scheduling. Seriously, if you've ever looked out at a factory floor or stared at a facility's dashboard and just wondered why things keep breaking down despite those seemingly endless maintenance schedules, you are exactly in the right place. We're going to completely rethink how we allocate our resources and protect our most valuable physical assets.
So picture this. Put yourself in the shoes of a maintenance tech on a typical Tuesday morning. Are they out there fixing a real, tangible problem, or are they just blindly chasing a checklist that hasn't been updated since, 2012? You know, a schedule isn't just a piece of paper. It's a decision that gets repeated thousands of times a year. It dictates exactly where your labor, your parts, and your downtime are actually going.
Here's our quick roadmap for today's explainer. We'll be hitting 6 main areas: why maintenance schedules fail, the high cost of downtime, choosing right asset strategies, defending corrective maintenance, answering common strategy FAQs, and finally, building a living schedule.
All right, kicking things off with Section 1, why maintenance schedules fail. Let's dismantle the absolute biggest myth in industrial maintenance today.
Here's the crucial thing you have to understand. A schedule is absolutely not just some calendar full of good intentions, things we just really like to get done if we have the time. No, it is a strict financial and resource contract. And where most programs completely fall apart is treating it like a wish list. They load it up assuming 100% wrench time, meaning they think technicians are turning wrenches nonstop, all day. But in the real world, organizations following strict best practice planning typically only hit a wrench time of about 60 to 65%. If you ignore your actual team capacity, your shiny new schedule is literally guaranteed to fail by Thursday.
And get this, there is a wild paradox going on across the industry right now. Recent reports show that 87% of facilities proudly claim to use a preventive maintenance strategy, yet 59% of them are spending less than half their available time actually executing those tasks. It's crazy. Everyone wants to do preventative maintenance, but nobody actually has the time to finish it, mostly because the schedule is just completely overloaded with unjustified, bloated tasks.
Which brings us to Section 2, the high cost of downtime. Because when that schedule only works on paper, the financial fallout is devastating.
Take a second and just let this number sink in. $253 million. Large manufacturing plants are now losing an average of $253 million every single year to unplanned downtime. That is a staggering financial bleed. A well-built schedule isn't some back-office paperwork exercise. It is the frontline defense that decides whether you're protecting your revenue or just hemorrhaging it.
And the reality of fixing things today makes an airtight schedule even more absolutely crucial. It's not just that things are breaking. It's that when they do break, they take way longer to fix. The mean time to repair has climbed industry-wide from 49 minutes up to 81 minutes. Why? Well, widening skills gaps and massive headaches getting parts, mostly driven by supply chain chaos. If you wait for a critical asset to just fail in today's environment, the penalty you pay in downtime is much, much harsher than it used to be.
So how do we fix this? That's Section 3, choosing right asset strategies. Veteran engineers definitely don't just guess when assigning work.
Instead, they build a bulletproof strategy by running every single asset through a really specific 4-step gauntlet. Step 1 is criticality, what actually happens if this thing fails. Step 2 is the failure pattern. Does it wear out predictably, or does it just fail randomly? Step 3 weighs the cost of monitoring it versus the cost of stepping in early. And Step 4 is resource availability. Can your team actually pull off the strategy you're proposing? An asset has to pass all 4 of these filters.
Because you simply cannot use a generic one-size-fits-all template. Think about it. Time-based preventative maintenance, like changing your car's oil every 3,000 miles, works beautifully for components with clear wear-out patterns, right? Things like belts and bearings. But it is practically useless for modern electronic control hardware. Take a PLC board, for example. Those tend to fail randomly. Swapping out a PLC board on a fixed calendar schedule doesn't prevent a random failure at all. It literally just wastes a perfectly good part.
Let's keep moving to Section 4, defending corrective maintenance. Now, we really need to address the elephant in the room here, because corrective maintenance has a seriously misunderstood reputation.
Corrective maintenance often gets treated like a dirty word, like a glaring sign that you failed at planning. But sometimes, letting a non-critical part fail is actually the absolute smartest financial decision you can make. Think about it. If an asset is low criticality, takes maybe 10 minutes to swap out, and you literally have 5 spare parts sitting on a shelf, why on earth are you wasting planned labor hours repeatedly inspecting it?
You end up spending expensive, planned hours trying to prevent a cheap, easy fix. The break-even math just has to make sense.
In fact, if you try to prevent literally every single failure, you run into this wild irony. Overscheduling preventative maintenance saturates your labor force, it adds cost without giving you any real benefit, and it kills your flexibility to handle actual emergencies. But worst of all, it actively introduces what we call induced failures. This is where we literally break perfectly healthy machines just by taking them apart to inspect them.
All right, Section 5, Answering Common Strategy FAQs. Since treating corrective maintenance as a valid, strategic choice is a pretty massive shift from traditional thinking, let's tackle the top questions that maintenance managers always ask me.
Question number 1. Is run to failure ever acceptable for critical equipment? The short answer here is no, absolutely not. While it's great for a non-critical conveyor motor, if an asset failing means creating a safety hazard or completely stopping production, the cost asymmetry is just way too huge. You never ever risk an unplanned safety event. You've got to rely on condition monitoring or inspection-based strategies there.
Next question. How does condition-based maintenance actually differ from predictive maintenance? You hear these terms thrown around like synonyms all the time, but they actually represent entirely different levels of technological maturity.
Think of it this way. Condition-based maintenance is a trigger. It's essentially telling you, hey, this machine is getting hot right now. It crossed a specific temperature threshold and you need to go fix it. Predictive maintenance, on the other hand, is like having a crystal ball. It uses machine learning and trend analysis to forecast the future. It tells you that based on current vibration data, the machine is going to overheat in exactly 3 weeks, giving you the power to schedule the downtime perfectly.
And then there's maybe the most common question of all. How do I prioritize when my team is completely drowning in work orders and just can't get to everything? Prioritization has to follow really strict, documented criteria. The order is safety and regulatory risk first, production continuity second, and the financial cost of delay third. It should never ever just be whoever happens to be shouting the loudest out on the factory floor.
That brings us to our final section, Section 6, Building a Living Schedule. How do we take all this great theory and actually bring it into reality without losing our minds in paperwork?
Well, you have to treat your schedule like a living, breathing model. It can't be some static document copied out of an OEM manual from 20 years ago. It has to constantly adapt based on 4 crucial metrics: failure history, criticality scoring, compliance rates, and the cost per asset. As new failure data rolls in every week, your strategy has to evolve right alongside it. If a specific task isn't actually reducing failures, you cut it.
Now, managing all that shifting data manually? Yeah, pretty much impossible. That's exactly where a structured CMMS platform like ManWinWin becomes absolutely essential. It gives you the exact tools you need, like automatic criticality scoring and real-time compliance tracking, to perfectly balance your preventive and corrective strategies. And the best part is it does this without all the bloated, confusing overhead you get with massive enterprise software suites. It lets your scheduling safely scale as your team matures. So, I'll leave you with this final, somewhat provocative thought to chew on today. Look at your own schedule tomorrow morning. Is your current planning board really reflecting the reality of how your assets actually fail, or are you just heavily funding decades of unverified comfortable habits? It is time to let the data dictate your schedule, not the calendar. Thank you so much for joining me on this explainer, and I highly encourage you to go reevaluate your asset registry today. Catch you next time.